Hi everyone, this is Dr. Orkun Baycek, and today we are going to talk about descriptive statistics. We are going to make an introduction. We are going to talk about the measures of location and measures of variability mainly in this video, and we are going to continue with the remaining parts of this descriptive statistics series in the upcoming videos as well. So, like I said, we are going to focus on the two main parts, the measures of location and measures of variability. So when I talk about measures of location, what I mean is we are going to look at the mean, the median, the mode, percentiles, and quartiles. Okay, so these are the main statistical terms that we are going to focus on. And let's go over them briefly to see and refresh our memory about what they mean. So the mean is pretty much the same as the average. So what we do is we sum all the values in our data set and then we divide that sum by the number of observations. Okay, so that will give us the mean of the data. The median is another measure of location, and that is the value in the middle when you sort all the values in your data set in ascending order. All right, so that will give you the median, and the mode is the value in your data set that repeats the most. Okay, so the mode has the highest frequency in your data set. The percentiles, the pth percentile, okay, so we are going to be looking at 70th percentile, 85th percentile, and so on. That percentile represents that about p% of the observations in your data set are less than the pth percentile. For example, let's say that I am calculating 80th percentile. An 80th percentile in my data set corresponds to 10. Value 10 is the 80th percentile. That tells me that about 80% of the observations in my data set are less than 10. Okay? That's what percentiles mean. And the quartiles are similar to percentiles. They're essentially specific types of percentiles. We are going to look at three types of quartiles, which are the first, the second, and the third quartiles. And the first quartile is essentially equivalent to 25th percentile, and the second quartile is equal to the 50th, and the third quartile is equal to the 75th percentile. Okay? The main goal in a quartile calculation is to divide the data into 4 equal components. Okay? So that is the main idea. And then next we are going to talk about measures of variability. Okay? The first one that we are going to look at is probably the most straightforward one, is the range. The range is equal to the difference between the largest data entry and the smallest data entry. Okay, so we are going to look at that. The second one is interquartile range, which is equal to the difference between the third quartile and the first quartile. Okay, the variance is probably one of the most commonly used measure of variability, and it is based on the squared deviations of the data entries about the mean. Okay, so that's what it represents. Standard deviation is the square root of variance, and we are going to see how that could be helpful in comparison to variance calculation. And the last one that we are going to see is the coefficient of variation, and it measures how large the standard deviation is relative to the mean in your data. And we report the coefficient of variation in percentages. Okay, so that is important as well. So let's get into an example. So I have a data set here which represents a number of employees' annual salary. Okay, so I have the data set in column A here. You can see that I have the first employee, the second employee, and so on. So I have 50 employees here. So I have 50 employees here in total. So what I'm going to do now is I'm going to calculate some of these descriptive statistics that we talked about. So the first one is going to be the average employee annual salary. Okay, so I have again 50 employees and I know their salaries. Okay, so if I look at the rest of the data, I have their salary information. And what I'm going to do is I'm going to calculate the average or the mean of the annual salaries. So I have two methods to calculate the mean. Again, remember, the mean is equal to the sum of all data entries divided by the number of observations. So here's what I can do. This is kind of a longer way to do it. I can use the sum function and I can sum all of these salaries. Okay, the salary data, I can sum all of these values. So it goes A2 up to A51. And then that will give me the sum of the employee salaries. Okay, so this is the sum. And the next value that I need is the number of observations. And to find that number of observations, what I can do is to use the count function and count how many entries I have in this data set. Okay, so again, A2 up to A51. If I count, what I have is 50 because I have 50 employees, and that verifies. Okay, so again, the mean is equal to the sum of all data entries divided by the number of observations. Therefore, I can calculate it by dividing the sum, which is the value in cell B2, divided by the number of observations, which is in B3. Okay, so that will give me the average annual salary, which is 91,660. But let's look at a different way to do it, which is by using the average function of Excel. And what I'm going to do is I'm going to enter my data set, so A2 up to A51, and this function will give me the mean, which is also equal to what we found earlier. Okay, so this is a shorter way. You can use the average function on Excel, and that will give you the mean of the data set as well. Okay, and the next descriptive statistic that we are going to look at is the median, and median has a function. So the nice thing about Excel is a lot of these descriptive statistics have a function, and the function names are essentially the same as the name of the statistic that you're interested in. Okay, so the median, we are going to enter A2 up to A51. Okay, so that will give me the median salary. Okay, the function I used, again, the input is the same because I inputted my data set in there, and the median function gives me a median salary of 92,500. Okay, so these are all different types of measures of location. So the mean and median can be different. Again, the median is equal to the median, the value in the middle when you sort the data in ascending order. So let's look at this. Let's say that I have a data set with 1, 2, 3, 4, 5. Okay, so this is already sorted from smallest to largest, and the middle value is 3, right? So the median is 3. But let's say that I have a data set with even number of entries. Okay, so these values on the left, let's highlight them in Scholar here. So with this data set, since I have an odd number of observations, the value in the middle is 3. But if I have an even number of observations, what I will need to do is to take the average of the values in the middle. So since I don't have a single value in the middle, what I will do is I will take the average of the values in the middle, which is 2.5. So the median in this data set on the right is 2.5. Okay, so that is a difference between having an odd number versus an even number of observations in your data set. Okay, so let's delete that. We don't need it. Next, we are going to calculate the mode. And again, mode has its own function, A2 up to A51. And that will give me the value that repeats the most, which is 96,500 60,000. So that is the mode in my data set. And then the next statistic that we are going to calculate is the percentile. So I have a random number of percentiles here. I'm going to calculate the 60th, 80th, 25th, and 75th. So there's an Excel function for that as well. So we are going to use the percentile function, A2 up to A51, and we are going to need to enter which percentile we are trying to calculate. Okay, so the first one that we are calculating is the 60th percentile. We are not going to enter 60. What we are going to do is we are going to enter 0.6, which represents the 60th percentile. Okay, so this will give us the 60th percentile, which is 96,400, and this tells me that about 60% of the values are less than 96,400 in my data set. Okay, so let's repeat it for the 80th percentile. Again, A2 up to A51. This time 80th percentile, so I enter 0.8, and that will give me 111,200. Okay, so that is the 80th percentile. Next, let's look at the 25th percentile, A2 up to A51, and 0.25 because we are looking at the 25th percentile. That is 76,500. And last, I'm going to look at A2, A51, 0.75 because we are looking at the 75th percentile. So what I want to show you here is, as you look at higher percentiles, right? So for example, when you go from 25th percentile up to 75th percentile, we are seeing that the value that it corresponds to also increases. And this makes sense, right? So if you have a data set and if you are looking at the value from which 25% of the values are less than it. So this tells me that 25% of your data values are less than 76,500. And obviously, a larger percentage of values will be smaller than 108,500, right? So that makes sense. As you go to a higher percentage in your percentile, then you should see that the value that it corresponds to will also increase, okay? So it's no surprise that as we are looking at a higher percentile, the value it corresponds to is also higher, okay? And then next, the quartile. So we are going to look at the first quartile and the third quartile here. So I can use a function called quartile, and again, we are going to enter our data set A2 up to A51. And in this one, our input will be 1 because we are looking at the first quartile. So that will give me the first quartile. And then the third quartile, again, A2 up to A51. And since we are looking at the third quartile, I'm going to input 3. And that will give me the third quartile. So let's look at what's going on. So look at this one. First quartile is 76,500 and 25th percentile is 76,500. And look at the third quartile. It's the same as the 75th percentile. So as I mentioned early in the video, the first quartile is the same as the 25th percentile and the third quartile is the same as the 75th percentile. And if we were to ask the second quartile, that is essentially the same as the 50th percentile, but it's also equivalent to the median. So let's show that. So the second quartile, so I'm going to use the quartile function A2, A51, and since we are looking at the second quartile, I input 2. That is equal to 92,500, which is equal to the median as well. Okay, so the second quartile is equal to the 50th percentile as well as the median in your data set. All right. And last, let's look at some of the measures of variability. So variance has two components. One is the population and two is the sample. So it really depends on if your data is a sample data or a population data. So we are going to assume that this is a sample data. And in that case, I'm going to use the function called var.s. So if it was a population data, I was going to use the function var.p. Okay, so this is a sample data. It really depends on what type of data it is, sample or population. And the input to this function will be your data set. So we are going to enter A2 up to A51, and that will give me the variance. Okay. Standard deviation, again, it can be a sample standard deviation or it could be a population standard deviation. You have two options to calculate it. You can do you can use this Excel function. Again, if you use .s, that means that you are looking at the sample data. If you use .p, you are looking at the population data. Okay, so that is an important distinction. We are going to input our data set A2 up to A51. All right, and that will give me the standard deviation. Another way to calculate standard deviation, if you already know what the variance is going to be to take the square root of the variance. So what I will do is to input the variance into my square root function on Excel, which will give me the same value. Okay? So here is the difference between the variance and standard deviation. Again, variance is based on the squared deviations for the data entries about the mean. Okay? It's the squared deviations. The standard deviation is the square root of variance. So what happens is the unit of the variance is going to be $square. Okay, so my data entries are all in dollars in terms of units, right? So for example, $82,000, $96,000. But the unit of your variance is going to be $square because that represents the squared deviations. But the unit of the standard deviation is still dollars, okay? So same unit as your data set. So that could be helpful to better understand the deviation, the variability in your data set, okay? So that is one of the main differences between the variance and standard deviation. The last descriptive statistic that I will calculate here is going to be the coefficient of variation, and that will be equal to the standard deviation divided by the mean. Okay, so we are going to calculate this value, but remember I mentioned that the coefficient of variation is reported in percentages. So what I will do is I'm going to I actually did it proactively. What you can do is you can either format this cell as a percentage, or you can basically divide the standard deviation by the mean and multiply this value by 100. Okay, I think this is a more straightforward way to do it if you're not very good at using formatting cells on Excel. So this is basically the same thing. The percentage is 19.78%. Okay, the coefficient of variation is 19.78. So again, what I did is standard deviation divided by the mean times 100. Make sure you put parentheses in the correct places because we are multiplying 100 by the result of this operation here. So make sure that you have the parentheses, and then the final value is your coefficient of variation. And an advantage of the coefficient of variation is that it doesn't have a unit, which means that you can compare different types of data in terms of the coefficient of variation to compare the measure of variability. For example, one of your data sets might be summarizing the height of employees, and the other could be summarizing the salary or weight of the employees. Although the units are different, for example, for the height, the unit is inches, and for the salary, it's dollars. you can still use the coefficient of variation to compare the variability in these two data sets. Okay? So this will conclude this video. In the next video, we are going to look at the second part of descriptive statistics. And thank you so much for watching this video. I will see you in the next one.